Hey guys, welcome back to the channel. It's Cari-math and I am here to make mathematics your superpower. I want to ask you guys, what if you saw one of these questions on your end of term examination or even the upcoming CSEC exam? How would you approach it? Let us perfect today the law of division. Alright, so before we even get into this question, we're going to derive the law together so you can see clearly how they got to that point. Alright, so step 1, we're going to write each of these values in index form. So currently they are in numeric form. We want to write them in index form and also expanded form. So we have 32 divided by 4, which is 8, and that is correct. Alright, so we want to rewrite 32 first, which is equal to, in a base of 2, 2 raised to the power of 5. And this 5, just a reminder, is saying to the base, you need to multiply yourself that many times. Kind of like a dictator. Alright, so we have 2 being multiplied by itself 5 times. So we have 2 times 2 times 2 times 2 times 2. Now we're going to have 4, and we want to write 4 in index form with a same base of 2, and our exponent, you guessed it, is also going to be 2. Alright, so that's going to be 2 times 2. Again, this exponent is telling the base 2, you need to multiply yourself that many times. Alright, let's get down to 8. If we have 8 to a base of 2, the exponent is going to be 3, which means that we need to multiply 2 by itself 3 times. So we're going to have 2 times 2 times 2. Alright, so let us rewrite all of this in the form of a fraction. So we're going to replace 32 with 2 to the 5th power, divide it by 2 to the 2nd power, and our result is going to be 2, which is 8, to the 3rd power. I wonder if you guys see the pattern coming out. Alright, if we should write this in expanded form, we're going to have 5 2's, and we divide that by 2 2's, and we can simply cancel a 2 in the numerator, in the denominator, with a 2 in the numerator. A 2 in the denominator with a 2 in the numerator, and that would give us 2 to the 3rd power. By the way, guys, please be reminded that you can only cancel in a numerator and a denominator. We cannot cancel 2 numerators or 2 denominators. Alright, so now we have the same base returning. What do you think happened with the exponents? I had 5 before and 2 in the denominator, and my result has now an exponent of 3. Alright, so we're going to try 2 more questions, and then maybe the pattern will be a little more clearer. Now we have 6 to the 3rd power divided by 6 squared. This is already in index form, so we're going to write this in expanded form. Can you guess what the answer will be? So we have 6 to the 3rd power, which is going to be 6 times 6 times 6. And then we want to divide that by 6 times 6. Perfect. Alright, so let's go ahead and cancel in the numerator and the denominator, so we now have 6 left, or the same as 6 to the power of 1. Alright, so we have to keep it in index form, and any value raised to the power of 1 is the value itself. And so we have 6 to the power of 1. Alright, so the base remains the same. What do you guys think happened with the exponents? 3 and 2. Last question, and then I'll give you the answer. So we have y to the power of 9. So we're going to have 9 y's. Let's write that out. So let's just write 9 y's. You can pause the video and try for yourselves. Alright, and then we have y to the power of 2, which means that we need 2 y's. Cancel 1 here, 1 in numerator, denominator, numerator. Alright, so now we have 7 y's remaining. 1, 2, 3, 4, 5, 6, and a 7. So we have y to the power of 7. So what do you think? What do you think, guys, just happened? Alright, so the law of division, I don't know if you notice, is telling us that we copy the base and we subtract the exponents. Very good. So we had 6 to the power of 3 here. We copied the 6 and subtracted the exponent. We copied the y. Our answer still has a base of y, except the numerator has been decreased by the number in the denominator, which is 2. Now, this expansion that we have done has a limitation because nobody wants to write out 54 p's or 19 p's. And that is why the law of division comes in handy when we have very large exponents or if we are working with negative values. And we're about to see that in the next part. All right, so we're going to now use only the law of division because we understand that the expansion method does have some limitation. All right, so number 1, again, check if your bases are the same. Check if the operation is division. So our bases are the same. We have 6 and we are dividing because the law cannot work if your bases are not the same or they cannot become the same or you are not dividing, right? So we want to copy the base and subtract the exponents. So we have 6 to the power of 5. Let's get down to number 2. Again, are our bases the same? Yes. Do we have the same? Are we dividing? Yes, it's in the form of a fraction, but this fraction bar still means that we are dividing. So we copy the base and we want to subtract the exponent. So we're going to have x to the power of negative 12 minus 5. I borrowed 12 and I borrowed 5, so overall I borrowed 17. Number 3, are my bases the same? Yes. Am I dividing? Yes. So I want to go ahead and copy that base and subtract the exponents. Now, as you can see, 9 does not have a clear exponent. And I hope you guys recognize because 9 can also be written as 9 to the power of 1 because any value raised to the power of 1 is the value itself. Alright, so we're going to copy that base and subtract our 1. So we have 9 to the power of negative 7. I owe 6 and I borrowed another 1. So overall I'm going to owe 7. Alright, last question. Am I dividing? Yes, I'm seeing my fraction bar. Are my bases the same? Yes. So I can go ahead and use that law. Now we want to copy the base and subtract the exponents. So I hope you guys recognize that I've been using the bracket because there are cases when you will make a mistake such as this, minus 9, minus 1. And this would not be correct. We are actually subtracting not 1, but we are subtracting that minus 1. So now that we see these signs beside each other, we have to treat it like multiplying two negative values. Alright, so we're going to start off by making these two signs become 1 and get rid of that bracket. So we have minus 9, negative times negative is a positive 1. Alright, and we are in a better place. I owed 9 and I paid 1. Overall, I still owe 8. Alright, so that is the perfect example. Let's get over now to some more complicated questions where we actually have variables coming into play, which are letters, and also not just letters, but these letters have coefficients. Question number 1, you want to separate the coefficients from the variable along with its exponents. So we want to take 10 being divided by 5, and we place it in those square braces, separating that. Then we want to separate y to the power of 9 with y to the third power. Do we have the same bases? Yes. Are we dividing? Yes. So we can go ahead and apply the law. So 5 into 10 goes 2. Y to the power of 9 minus 3 is y to the power of 6. Number 2, we're separating the negative 2 and the negative 4. I'll place those in square braces. Now we have p to the third power being divided by p to the power of negative 2. So we're going to cancel 2 into itself 1, or negative 2 into itself 1, and negative 2 into negative 4 is 2, because negative divided by negative is a positive, or you can say the signs have cancelled out each other. So we have a half. Now we have p, which is in our numerator. to the power of 3 minus the denominator, and I'll put that in bracket, and that's going to be a minus 2. Therefore, we are going to have half p to the third power. Negative times negative is a plus 2. Alright, so we finally have half p to the power of 5. And lastly, we want to go ahead again and separate our coefficients. So we have 20 being divided by negative 4. We're going to put the x's together. We have x to the 5th power being divided by x. And then we have y to the 8th power being divided by y squared. So I've separated all categories just to make it clean and clear. So we have a negative 5 here. X to the power of 5. Again, this x doesn't have a visible exponent, so I'll make the exponent 1, or it means that the exponent is 1. So we want to subtract a 1. And lastly, let me be consistent with the bracket. Lastly, we have y to the power of 8 minus a 2. Alright, so our final answer is going to be negative 5. X to the power of 5 minus 1, that's 4. And then y to the power of 8 minus 2, that's going to be a 6. By the way, this is a negative 5 because a positive divided by a negative still gives us a negative. Now, we're going to look at the last situation. You don't have to stick around for these, but these are going to be all the cases where we do not have the same base or we're not dividing. How do I approach questions like these? Number 1, for case 1, this is when we have same bases, but we're not dividing, so we have a different operation. Alright, so what we want to do is evaluate each individually, because the law in this case is not applicable. So we're going to have 6 squared, which is 36, plus 6 to the power of 1, same as 6, and that's going to be 42. Again, for case 1, part 2, you notice that the bases are the same, but you're not dividing, which means that the law is not applicable. Alright, and because we are working with variables, these are not like terms, the value of the exponents are different, it cannot be further simplified, so you have to leave it as is. Case 2, that's when we have the correct operation, but different bases. As you can see, we're dividing in each case, but we do not have the same base. What we can do, however, is evaluate each value individually. So we have 2 cubed, which is 2 times 2 times 2. That's going to be 8. Then we want to divide that by a 3. So our final answer in the form of a fraction is 8 divided by 3, 8 over 3. Or we want to write it as an improper fraction, which is going to be 2 and 2 over 3. Last part, again, the law was not applicable. In this case, it's not applicable either because we do not have the same basis. However, this cannot be further simplified because we do not have like terms. We have to leave it as is. Last question is a mixture of both. We don't have the same sign. We don't have the same basis. The law cannot be applied. So we have to evaluate individually. 3 squared is 3 times 3 plus 2 to the 5th power is 2 times 2 times 2 times 2. So when I'm finished, I have 2 3s and I have 5 2s. So 3 times 3 is 9 plus 2 to the 5th power is 32. And that makes my final answer a total of 41. That's it, guys. Thank you for watching the video. You can go back to my former video about the law of multiplication, which will be posted somewhere here. Thank you guys for the support. If you have any suggestions, drop it in the comment section and I am willing to serve you. God bless you.